In this video, we are going to continue off from our last lesson of simple interest. So we're still going to talk about interest, but not simple interest this time. We're going to talk about compound interest. And as you will see, compound interest is very different from simple interest, okay? And we are really going to take advantage of the idea of compound interest in order to help us get rich, okay? So what is compound interest? Compound interest is interest that is paid on the principal and on all of the interest that you have already been given, okay? So before I show you the formula, I just want to go over the idea. So last lesson, you had $1,000 principal, 10% interest rate. So 10% of 1,000 is 100, 100, 100, 100. So you kept getting $100 at the end of every year. But this is how compound interest works. So you still have a principal of 1,000. Let's say the rate is 10%. Okay, 10% per year. And let's say, one second, it's interest rate. And then interest earned. So if it's 10% after 1 year, so after 1 year, we're looking at $100. So the amount you have after 1 year is $1,100. And you're thinking, wait a minute, that's exactly the same as what we had, with simple interest. But wait a minute, after first year, it gets a little more exciting. So after 2 years, yes, you have a principal of $1,000. Yes, let's say your interest rate is still 10%, but hold on. The interest you earned is not going to be $100. In fact, let's go back to our definition. It's interest that is paid on the principal and on the interest as well. So the interest you earned from the after the first year, that's earning interest. You're earning interest on interest. So if you think about it, 10% of 1,000 is 100, and 10% of 100 is 10. So you're earning $110 instead of just 100, which means your total amount is $1,210. Beautiful. And after the third year, let's keep that 10% going. So you're going to earn 10% on the $100. Sorry, 10% on the $1,000, 10% on the interest you earned in the first year, after the first year, and interest you earned from the second year. So that's 10% of 100, 10% of 110, and 10% of 1,000. So that's 100 plus 10 plus 11. Okay, that's 121. So that's going to be 1331. Okay, so the interest you earn is earning you interest. That's why the effect is being compounded. Your money is growing rather nicely with this idea. So because the interest is earning interest, we call it compound interest. It's not just the principal. With simple interest, it was just the principal earning you interest. But now, the interest is earning you interest, which is a very powerful idea. So to really stress this fact, why it's a powerful idea, let's look. Look at the formula here, okay? Before we even talk about what the letters represent, look at the formula. This is an exponential function. Exponential function, you know what? Without even doing the examples, without even doing the math, this is what we need to say to ourselves. Okay, you want to ride the wave. You want to ride the exponential curve. Okay, and in order to take advantage of this curve, what the function is telling you is that you need to let n be a great number. Okay, how great? Well, that depends, but you just need to invest for a long time. You got to play the long-term game. If you play a short-term game, what the equation is saying is you're not going to ride the curve, the exponential curve. You've played a long-term game, you'll reap the benefits. Okay, it's really that simple. That's the basics of money. Yeah, so you really want to take advantage of this exponential. Like if you have the knowledge of exponential functions, let's make use of that. Okay, compound growth, like compound interest, really works like an exponential function. So what is A? A is the amount that you're going to have in the future. P is the principal. I is the interest rate. And N is the number of compounding periods. We're going to talk about compounding periods in a second in more detail after the first few examples, but we'll keep it simple for the first two. So let me show you what I mean. Jimmy invested $5,000 into a bank account that pays 6% per year, compounded annually for 10 years. What that means is that he's going to get 6%, the interest rate is 6%. So let's do the first example. We have Jimmy invested $5,000 into a bank account that pays 6% per year, compounded annually for 10 years. How much will the investment be worth at the end of 10 years? So what that means is that he's getting interest at the end of each year for 10 years, okay? And the effect is being compounded. So the future amount, you have 5,000, that's your principal. 1 plus 0.06, raise that to the power of 10. So looking at $8,954.24. Not bad. Okay, now how much of this 895 interest? Well, of the 8954, 5,000 of that was his. So I is equal to A minus P, which in this case is $3,954.24. So I don't know if you're impressed with the $4,000 interest, like almost $4,000. Are you impressed with this or are you not impressed? Well, I'm personally, I'm on the fence. I'm happy, but at the same time, I'm not ecstatic. So how do I make myself happier? What you should do is not just invest it for 10 years, invest for 30 years. If you let N be 30, I want you to do the math on the side and compare the amounts. You earn a lot more interest if you let N be 30. If you invest for 30 years as opposed to 10 years. Why do you earn that much more? Because it's an exponential function. So take your time. I highly recommend you. I want you to do the calculation. Okay, let it be 30 years. You know what? Let's just do it very quick. Whoa. That's a lot more money. Okay, that's 20, let's say 29,000 compared to 9,000. Okay? That makes a big difference, right? You really want to ride the wave. Now, I would argue 29,000 is not that good. Well, it's way better than 5,000. But why is he not closer to becoming a millionaire? Because he only invested $5,000 into the bank. Okay, it's only a principal of 5,000. It's not a small amount, but it's not a big enough amount to make you filthy rich. Okay, because you more than quintupled your money over 30 years. But quintupling 5,000 only gives you so much, right? You need 1,000 thousands to become a millionaire. So you gotta work with the numbers here. All right. So Susan has $5,000 too, but wow, she was able to get a rate of 12% per year compounded annually. Same thing, 10-year timeline. So let's see. So why did I do this question? Because I doubled the rate. It went from 6% to 12%. And I want you to understand that when you double the rate, you don't double the interest earned. Okay? It's not proportional because we are talking about an exponential function. All right, so interest earned. So take away the 5,000, which is his or her own money. So that means of that, that's $10,000 worth of interest. Okay. So therefore, wow, that's really good. That's more money than she put in to begin with. She earned, let's say, 10,000 worth of interest, and she only put in 5,000. And for the same idea, what I want you to do is, increase the timeline. Really ride the exponential curve, and see how much money she has after 30 years. Okay. I always have students giving me some morbid examples after I teach this lesson or these examples. They say to me, Miss Lam, I really want to spend my money. I don't want to save my money because they say YOLO or something really silly to me. They say, if I die tomorrow, what's the point of saving? And you know what? That's a hard counter argument. So my counter argument to those statements or those sentences that, you know what, I won't say how old I am, but if I happen to die tomorrow, I'm okay with that. I'm okay with the fact that I didn't get to spend my money. I'm not going to be angry over it. I'm very content with the fact that I saved my money because I can give it to my wife. I can give it to my kids. If I had no wife, I had no kids, I'll just give it to a charitable foundation, a charitable cause. So I have no qualms with saving my money and not spending it. Okay, and I think that's something you just have to learn to be comfortable with. Okay, let's do the next example. In the previous two examples with Jimmy and Susan, the compounding periods were annual, which means you collect interest at the end of the year. But that's not always the case. For example, you can have semi-annual compounding periods, quarterly compounding periods, or monthly compounding periods. And that does affect the math a little, so let's take a look. If we're compounding annually, that means the interest rate per compounding period is I, and you have one compounding period per year. Now, if it's semi-annually, that means you're collecting interest 2 times a year as opposed to 1 time a year. So you collect interest 2 times a year. Now, the interest rate per compounding period is I over 2. And there's 2 compounding periods a year. If it's quarterly, it's I over 4 times a year. I over 12 for monthly, it's 12 times a year. Bi-weekly is 26 times a year. Weekly is 52 times a year. Daily is 365 times a year. Okay. So how does that affect the math? Let's take a look. Philip invests $5,000 for 7 years at 4% per year, compounded semi-annually. So be careful. You're not compounding annually, it's compounded semi-annually. How does that affect the math? So now A equals $5,000, 1 plus 0.04, and you're going to divide it by 2. You're going to take 0.04 and you're going to divide it by 2 because the interest rate per compounding period is not 4%. The interest rate per compounding period is 2%. And it's twice a year for 7 years, which means it's 14 compounding periods. So that works out to be 6597.39. So the first three examples I would say are pretty positive. You put money into some account, it grows, good vibes, lots of good vibes. But, you know, the flip side of the coin is when you are borrowing money. When you borrow money from the bank, they're gonna squeeze every little penny out of you. So let's take a look at what happens when you borrow money. The first thing you should notice that when you borrow money, the rates are really high. When you're comparing the rates, like a borrowing rate and an interest rate, the difference is staggering. So you know what? You go online, do some research, and you'll see the difference. Okay, so Mark borrows $20,000 to start his own cheese business. Interest rate is a whopping 10% per year, compounded monthly. He's expected to repay the loan at the end of 8 years. So how much does he owe after 8 years? I'm scared to do the calculation. So divide by 12, because that's the interest rate per compounding period. 8 years, 12 times a year, 8 years, that's 96 compounding periods. So we are looking at $44,363.51. That is a little depressing, but you know what? That's reality. So let's calculate how much of that 44,000 is interest. Well, he didn't borrow 44,000, so a lot of this money he's paying after 8 years is not actual money he used to start his own cheese business. In fact, if you subtract by 20,000, the cost of borrowing, which is $24,363.51, is greater than the amount he borrowed initially to start the business. That is insane. Okay, so this is not realistic, just to let you know, because the banks will not do this to you, because what's very, very likely to happen is that Mark doesn't have 44,000 after 8 years, and then yeah, that's just a messy story that the banks don't want to deal with. So what is realistic is that Mark will borrow $20,000 and he has to make monthly payments in order to pay off his loan. That's how loans work in real life. But yeah, why did I give you this question? Because no matter, okay, so every time you borrow money, whether it's to buy a car or buy a house, or buy something, like a refrigerator. If you're borrowing money, you should really calculate the cost of borrowing. You don't want to be surprised. You don't want to pay the money and say, wow, it costs that much money to borrow money from the financial institution. So you don't want to do that. You don't want to be surprised by the cost of borrowing. Do the math, calculate it, and say, you know what? If the cost of borrowing is exceedingly high, then maybe you shouldn't get that big house. Maybe get a smaller house. Maybe you shouldn't get that super, super fast, nice, fast car. Okay, so do the math, and you won't be sorry about it. You don't want to be surprised. Okay, the second thing I want to quickly mention is that is it fair that Mark has to pay this amount of money in interest? So most people will say no, but then there'll be the odd student who says to me, wait a minute, it's actually, like Mark consented to this, first of all, okay? And secondly, he might become a multi-billionaire selling cheese, okay? So, and without the bank's help, he couldn't have done that. So that's another take or another perspective on the situation. But you know what? At the end of the day, you should be able to do the math and answer the questions for yourself. So you can make a wise decision.